This question requires us to solve this inequality and hence using the result solve another inequality. And we are going to try solving this inequality without using our graphing calculator. So the first thing that we will do is we will make sure that one side of the inequality is equal to 0 by bringing the 1 over to the left hand side. And for the non-zero side, we are going to consolidate and try to factorize them into multiples of linear expressions. So here x squared minus x minus 1 minus x plus 1 divided by x plus 1. This is less than or equal to 0. So we have x squared minus x is minus 2x minus 1 minus 2 divided by x plus 1. This is less than or equal to 0. The denominator is already a linear expression, so for the numerator, which is currently quadratic, let's try to factorize it. And to do that, you can either use the quadratic formula to find the roots of this quadratic expression, or we can do a completing square. I prefer completing square, so it will be x minus 1 square minus 1 minus 2, which will be minus 3, divided by x plus 1. This is less than or equal to 0. And if we can just change our perspective to look at 3 as if it is a square root of 3 square, then we can apply the a square minus b, which will be a plus b, a minus b. So it will be this plus square root of 3, then x minus 1 minus square root of 3, divided by x plus 1. This is less than or equal to 0. And I'm going to draw the number line, putting in numbers that will be causing each of the linear factors to be 0. So for x is equal to minus 1, it is going to cause the linear expression in the denominator to be 0. Likewise, for this, we will have a 1 minus square root of 3. 1 minus square root of 3, and it will be a 1 plus square root of 3 here. Okay, and substituting a number that is bigger than 1 plus square root of 3 into this entire expression, we will be getting a positive number. So I'm going to put a positive here, doing likewise to the 3 other intervals. Here will be negative, here will be positive, here will be negative. So the range of values that is going to be causing this entire expression to be less than or equal to 0 will be this region here and this region here. But since x cannot be equal to minus 1, or else the original inequality is going to become undefined, the denominator will be 0 if x is equal to minus 1. So we are going to be keeping x to be strictly less than minus 1. And as for this interval, x is going to be bigger or equal to 1 minus square root of 3, less than or equal to 1 plus square root of 3. Okay, so now this is the answer to my first inequality. We are going to be using this to try to solve this other inequality. And for this, we have to do a comparison. Okay, and if you were to compare those terms that are already independent of x, for example, 1 is still going to be 1, minus 1 is still going to be minus 1. So I don't really want to do too much manipulations to this. In fact, I probably will want to just do a comparison like directly. For example, there's still one more number, which is this plus 1. Plus 1 is still the same as this plus 1. It's just that they are swapped, which means that if I can just do a quick swap to the denominator, rewriting it as this, then plus 1. Are you able to see? Okay, from my observation, it seems like all the x are supposed to be replaced by negative modulus of x. Let's try in the numerator here. So it will be minus 1 here. This, if I can rewrite it as minus modulus of x, then it's synchronized to this. Similarly, for this x squared, if I were to replace it by minus modulus of x, then square, I'm going to be getting this. Okay, so this is less than or equal to 1, and with this observation, we can be quite certain that all the x, as long as we replace them by negative modulus of x, I will be able to deduce the answer based on this. So let's do a replacement for this also. Negative modulus of x is less than minus 1, or negative modulus of x is going to be between these two numbers, 1 minus square root of 3, then 1 plus square root of 3. For this that is here, I will definitely multiply a negative throughout, giving me this. And algebraically, I think this is easy for us to just based on what we have in our lecture notes or on the Achevas TV to deduce the solution to this. Let me write it down here. So for this, it is going to be x, that is to be less than minus 1, or x is going to be bigger than 1. Okay, as for this, I don't really encourage us to attempt to solve this too algebraically. I think an even more efficient and accurate way, right, for us to be solving this is to actually draw the graph. Okay, so we can definitely draw the graph of y is negative modulus of x. Or maybe, to me, I find it simpler if I were to multiply it by a negative throughout first, which will be giving me this as a minus 1 minus square root of 3, and this will be minus 1 plus square root of 3. So I will be drawing the graph of y is equal to modulus of x instead. Simple graph. So if I were to use graph to try to solve this inequality, let me draw a quick sketch of it here. So let's say this is going to be the 45 degree and 45 degree here to represent y is equal to modulus of x. I'll need two other y values. One will be y is equal to minus 1 minus square root of 3. The other one will be somewhere here, minus y is equal to minus 1 plus square root of 3. Okay, it is a positive value. And in order for us to make use of this graph to solve this inequality, where now this modulus of x is represented by the y coordinate of this graph, so what we need to do is to just check when will the y coordinate that is on this graph be between these two values. So it is actually just this portion where y is between these two values, which means that the set of values of x that will satisfy this inequality will be this value here and this value here. And to find these two values, they are so simple because we have a very easy to analyze modulus of x over here. Some of you probably can do it using just simple mental sum, or we can definitely write it down by letting modulus of x be equal to this minus 1 plus square root of 3. So x is going to be plus or minus minus 1 plus square root of 3, which is minus 1 plus square root of 3, or 1 minus square root of 3. Okay, so with these two values, let's plug it in here. We have 1 minus square root of 3, which will be this. It's a negative value, 1 minus square root of 3. And minus 1 plus square root of 3 is here. Minus 1 plus square root of 3. Okay, it is the positive value. So this is the set of values of x. That is why my final answer will be for x to be between minus 1 plus square root of 3 and 1 minus square root of 3. Okay, oh, sorry, I've arranged them wrongly. Let me rewrite this. So x is supposed to be between two values. One will be 1 minus square root of 3. The other one is minus 1 plus square root of 3.